Okay guys, welcome back. Your favorite science teacher, your only science teacher these days. Want to progress through the electricity unit now and talk a little bit about the equations involved in determining some of our mathematical solutions for different things. Okay, so first let's get our notes going. And we've always called it a cheat sheet. It's more of a study guide, maybe we'll call it, where you have all the information you need to then use to help you solve problems, okay? And when we're back in school for our final exams, you'll be allowed to use this cheat sheet, okay? First thing we'll talk about is Ohm's law, okay? And again, everything is very sequential and builds on itself, so you're going to need the first note we did, handy, which was all your terminology, right? Hopefully you have something like that, and then we'll just build on it. Okay, so you need to know the symbols now to understand the formulas. Ohm's law is the relationship between resistance, voltage, and current. Okay, resistance is voltage divided by current. And if you place all three variables in this sort of a triangular arrangement, it's a helpful guide for you to solve any one variable so long as you know the other two. And that's how all the triangles will work, right? So for instance, if you're ever given voltage and current and you're asked to find resistance, you would cover up kind of resistance, and it's going to be voltage divided by current, just like that says, right? If you're ever asked to find voltage and you're given resistance and current, you would cover up voltage and you're left with the resistance multiplied by the current, okay? That's how these triangles work. So anytime you're given two of the three variables, you can easily figure out the third variable by just doing the math that is suggested, okay? If it's side by side, you're multiplying these to get that. If it's one above the other, it's top divided by bottom to get the third variable. And we'll do a couple of examples, so don't worry. Next up, you've got the relationship between current, charge, and time. Current is charge divided by time. And then we can set up a triangle like this where we have current as I, charge as Q, and time as T. Same thing for voltage, energy, and charge, V, J, and Q. And then I added a couple just kind of standalone equations to help you out. I noticed some of the math later on, if we get to it, to really challenge some of you guys, you might find these two equations useful. Okay, and they strictly deal with power. And this would only come into play when you have a two-part question. Okay, the first few will be very straightforward. You'll only ever need one triangle. I'll give you two out of the three. You calculate the third. But sometimes you'll be given a fourth variable and a triangle will not be enough. So you'll have to do one thing to get information to then use the triangle to then get your answer. Okay, so we won't worry too much about that today, but I'm giving it to you now anyway so you can put it on your cheat sheet. Power is voltage times current. Power is also joules, or energy divided by time. Okay, so if you don't have all that written down, now's a great time to hit the pause button and get it all down. Okay, maybe you have just hit play again. If you don't want to see me write out boring questions, then you can hit pause again. So I'm going to give you the first question here. A charge of 20 coulombs passes through a toaster every minute. Hopefully right now you're thinking, oh, a minute, 60 seconds, because we know time is always in seconds for this electricity math. And the question is, what is the current? So we've immediately been presented with two variables of data that were given and we're asked to find current. Okay, so I'm going to suggest we go with the old equation that had current equals our charge over time. Okay, we're given a charge and we're given a time. Okay, we're asked to find the current. So quite simply, to do that, we're going to go current equals charge divided by time. We're going to go 20 coulombs divided by 60 seconds, and that's going to give us 0.3. 0.3 watt, right? All this math is super important. You guys have units attached to these numeric values, otherwise you're only getting half the marks. Current is measured in amps, so there's your final answer. Okay? Not too tricky, I hope. Press pause if you need to. Kind of like this. When we're in the classroom, you guys are always shouting, hey, 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 wait, wait, wait. Now all you have to do is hit pause. Number 2. What's the resistance? If you're a Star Trek fan, you're probably always thinking resistance is futile. If you know what the Borg is. What's the resistance when you have 50 volts, 50 volts, and 25 amps? So we're looking at a classic Ohm's law question here. So that's your first triangle you were set up with. I've given you 2 data points and you're simply asked to find the third. Okay? You're going to get a worksheet to do a bunch of these in the note package once you check on it. And you'll notice that the first 2 questions are exactly the examples we're working on. So that should help you out. Okay? So what I like to do is set up the equation that you're given. Resistance equals voltage over current. Usually we give you guys marks for all these steps, so it's very important you do the steps. Set up your equation, sub in your known variables. So we've got 50 volts and we've got 25 amps. That's a nice easy set of numbers to work with, eh? 50 divided by 25, we're looking at 2. Is that our final answer? Of course not. We need our units for resistance, and we're going to say it's 2 ohms. Okay? I think those are 2 good example questions for you guys. The only way you're going to get really good at it is if you practice. So if you now check the notes that were attached in the workspace for this lesson, you'll see this page as one of the notes. This is all just repetitive because in school I would cut it all out and give you small pieces. So we've just done the first 2. See if you can do the first 2 again all on your own without help, and then work your way down through 3, 4, 5, and 6. Okay? And if you guys can get through that this week, all of you, I think that would be fantastic. Okay? Applied kids, that would be it for the math for a bit. You guys can focus on some of your other stuff. Academic kids, I'm probably going to throw another lesson up for you on circuitry and a little bit of math for that. Okay? And again, I said this in the workspace. You're getting a little bit more than 3 hours a week, I'd say, for these 2 weeks. But I'm allowing you 3 full weeks for the unit. So basically the third week will be time for you to finish up any of the math lessons and or your project. You're going to get a fun, new, exciting project to do, and you can chip away at that into week 3. Okay? Thanks, guys. As always, you can email me any questions you have, and we'll go from there. Thanks.